Okay, today we're going to look at, I think this is page 10 in your packet. It's the last pages in your packet, solving trig functions. So last class we looked at verifying, where we showed how to simplify. Now we are solving. So all these equations have had an x in them, and now we're going to figure out what x actually equals. I don't have my packet with me, but I rewrote all the problems from your packet. And on the top of page 10 here, I want us to take some notes. So we're going to be using these inverses, and we have to recall from when we graphed inverses earlier that these three inverses only exist in two quadrants. Sine only exists in quadrant 1 and quadrant 4. Cosine is 1 and 2, and tangent is 1 and 4. Make sure you take these notes at the top of your paper because this is going to be helpful when determining all of our answers. Okay, pause this video if you need to write down. I'm going too fast. That's the beauty of a video. But first, in the first section of problems, we have an interval that they give me. If this means they only want our answers to be between negative pi over 2 and pi over 2. So if I look at my unit circle, let's draw it up here too. And we know pi over 2 is at the top. That means negative pi over 2 is at the bottom. So if my interval is from negative pi over 2 to pi over 2, that only represents quadrants 1 and quadrant 4. So not only do we have restrictions with our inverse functions, but we also have a restriction with our interval. You will need a unit circle for today's lesson, so go ahead and pause this video and open another tab or find the one that you have on a piece of paper. Okay, I do want to skip around on this first page. I want to start with number 5, and in number 5, I do want you to correct your problem on your paper to look like this before we get started. So if we're going to solve for x, I need to get all the x's on one side and all the numbers on another. So if I have 3 cosines, let's subtract a cosine to get 2 cosine, right? 3 minus 1 is 2. I'll leave everything else. Still trying to get x by itself, so let's add the 2. Divide by 2. So now the last thing I need to get rid of is cosine. When you bring cosine to the other side, any trig function, that's when you get the inverse. So in order to solve for x here, I need to solve for the cosine inverse of 1/2. So here's where we have to pay attention to our restrictions. Cosine only exists in quadrants 1 and 2. So that's the only place I can look for this answer. Well, on your unit circle, quadrant 1 has the positive answers, quadrant 2 has the negative answers. We want a positive number, so I'm going to be looking in quadrant 1. Now we have to double check our next interval. Am I allowed to look in quadrant 1? Yes. Okay, so let's all look in quadrant 1 for where the cosine is 1/2. Remember, cosine means x value, so where is the x value? 1/2 in the first quadrant? That happens at pi over 3. So this is our answer. And that's how solving works. All right, let's do another one. Let's go to number 1. Number 1, still working to get x by itself. So let's move that root 3. Again, pause this video if you need time to write. Divide by 2. And now to move cosine, it becomes the inverse. And now we need to solve. Remember, cosine inverse only exists in quadrant 1 or quadrant 2. This time I want a negative answer, so I'm going to be looking in quadrant 2. But look at your other restriction. Are you allowed to look in quadrant 2? No. Since this is in quadrant 2, I'm just not allowed to look there. That means my answer is undefined. So if your restrictions make you not able to solve, your answer is undefined. Okay, Number 3 on your paper is a little tricky because it's a weird algebra problem. A lot of you are going to screw up because you're going to say, hey, let's divide by 2. I cannot divide by this 2 until I get rid of sign. So this 2x is going to stay. Let's move the sign and become the inverse first. So now in order to solve for x, I need to figure out who this is first. So let's ignore the 2x for now. We'll leave her here. Sine inverse, we know, is quadrant 1 or 4. But if I'm looking for a negative value, quadrant 1, sorry, let me fix my paper. Quadrant 1 is all the positive values. So I'm going to be looking in quadrant 4. I am allowed to look in quadrant 4. So in quadrant 4, the y value is -1 at, I'm going to put this over here for now. Let's do 3 pi over 2 at the very bottom. Okay, the reason I put this over here is because they don't want me to say 3 pi over 2. Because of the interval, they want us to use these negative numbers. So it does exist, it is -1 at the very bottom, but instead of saying 3 pi over 2, we have to say negative pi over 2 because of the interval. From here, we still haven't solved for x, so I have to divide by 2. Negative pi over 2 divided by 2 is negative pi over 4. That's our answer. So this one, the pre-cal wasn't hard, it was the algebra. But you're okay, I believe in you. Okay, number 7 on the same page here. Okay, what's weird about this one? This one's a little stressful because we have 2 different trig functions. But that's okay. All that means is we're going to have 2 answers. Now, a lot of algebra-loving people want to just divide both sides by sign so they can cross the signs out. We cannot do that here because if we cross out a trig function, we are crossing out an answer, meaning you'll only get half the credit. So let's not do that. Instead, anytime you see 2 trig functions, I need to make my equation equal to 0. So let's subtract the sign. Okay, now both of these terms have a sign in it. So I'm going to simplify by factoring out a sign. It's like I'm undistributing. So what's left here would be √3 tangent x minus, if I take a sign out, I'll be left with a 1. So if I redistributed the sign, I would get my original function. Okay, once you factor something out, here are 2 new equations. Sine x and then √3 tangent x minus 1, they'll both equal 0. So I'm going to rewrite both equations. And now I have 2 problems to solve. Let's start over here. So I'll do the sine inverse. And I'm just looking for 0. So where on your unit circle is the y value 0? Look around, look around. Where is the y value 0? That happens at 0. We could also say 2 pi, but because of our restriction, 2 pi doesn't exist in there, so we have to use the 0. Okay, for the other side, we have a little more moving around to get x by itself. So first, I'm going to add the 1, and then divide by that √3. Now we'll take the inverse. Okay, remember, cosine is x, sine is y, but tangent is y over x. This is a positive number, so let's look in quadrant 1 for our positive numbers. So we're looking for where is the y value 1, where is the x value √3. Remember, the trick here is you can ignore the denominators, you can ignore those 2's. So where is the y 1, x √3? Look on your unit circle. You'll find it at pi over 6. Double check, make sure you know how to find it. Ask me a question? No questions? Great. Last one we're going to do on this page is number 6. Number 6, different because it has a reciprocal identity, but that's okay. First step is let's just get x by itself. So I'll divide by that root 2, and then secant inverse, and I'm chilling here. We don't know where secant is, so I'm going to change it to its reciprocal. The reciprocal of secant is cosine. If you change secant to cosine, you have to also flip this fraction. So now we're chilling. This is a positive number, so I'm looking in quadrant 1. That's in my interval. Where's the x value, root 2 over 2? That happens at pi over 4. Okay, one more, then we're done. Okay, I don't really know what number this is. This is on the next page of your packet. I think it's number 13. It might be number 12. I don't know. Find this problem. It's like under like the second section on the next page. A big deal here. I do want to change the interval from what it says to 0 to 2 pi. By changing this interval, that means I can use the whole circle, except I just still have to pay attention to these restrictions. But otherwise, I can use the whole circle. Okay, on this problem, we have one trig function. They're both cosine, however, one is squared. This means when you have a squared and a not squared, what you're going to do first is rewrite your equation not using the cosines. So I'm going to rewrite this equation to say 2x squared minus 5x minus 3. When you see a problem like this in any kind of algebra class to solve for x, you know that you're going to have to factor. So if I'm going to factor this problem, I would say 2x plus 1, x minus 3. Hopefully you know how to factor. Okay, once we factor it, I'm going to come back here and use these numbers, and wherever I see an x, I'm going to put the cosine back in. So my function will now say, let's do it here, 2 cosine x plus 1 and cosine x minus 3, it all still equals 0. So I factored it, put the cosines back in. Here, I again have 2 different problems that we need to solve. So let's rewrite them and set them equal to 0. Okay, I'm going to work on this left side first. So let's get x by itself. Okay, so I'm getting the cosine inverse of -1/2. Cosine inverse only exists in quadrant 1 and quadrant 2. If you're looking for a negative number, we're going to look in quadrant 2. This interval says, hey, we can look in the whole unit circle. That's great. So everybody's looking in quadrant 2 for the x value is -1/2. And that happens at 2 pi over 3. Yay! Okay, next one. Still get x by itself. Okay, we have an issue here. 3 is not a number I'm going to be able to find on the unit circle. What that means is this is our answer. It's not on the unit circle, so I don't know how to evaluate it. So let's talk about a difference, because a lot of people want to say this is undefined. Undefined is when you have a number you can use on the unit circle, but your restriction makes you not able to say the answer. That's undefined. When you have a number that's not on the unit circle, we'll leave her as our answer. Okay, now the last thing you have to do is your homework assignment. Your homework assignment is right above this problem. I think it's number 12. Sorry, guys. But here's the problem that you're doing. I will give you a hint. You will need to factor this. So this will turn into x squared minus x minus 2. And you should be factoring this into x plus 1, x minus 2. So your job now is to put the sign values back in and solve for both sides for x. Take a picture of it, post it on Schoology. Bye!